There's a simple question that more people need to ask right now, and it's one that isn't getting the attention it deserves. What happens when a technology becomes so advanced, so widely used, and so deeply embedded into everyday life that people stop questioning how it actually works? That's the moment when assumptions take over, and assumptions are never a safe foundation to build the future on. Artificial intelligence has reached a point where many people treat it as stable, dependable, and predictable. The truth is far more complicated. Behind the calm surface, the technology is growing at a speed that even the most informed experts didn't expect. And while that growth brings huge breakthroughs, it also brings risks that are easy to overlook when everyone is focused on excitement instead of structure. Right now, we're living through a moment unlike anything we've seen in modern technology. A single system can write, code, research, summarize, analyze, and reason. It can assist professionals in fields that once required decades of study. It can produce answers in seconds that used to take days. That kind of capability naturally creates a sense of confidence. People start to believe the system understands the world in the same way they do. They trust it to make decisions. They trust it to tell the truth. They trust it to fill the gaps in their own knowledge. But trust becomes dangerous when it grows faster than understanding. These models are not built on awareness. They don't see the world. They don't have memory in the way humans do. They don't form intentions. They don't pause to question themselves or verify their own output. They respond based on patterns, predictions, and training, not lived experience or judgment. Yet millions of people treat the responses as if they come from a source with reasoning identical to a human expert. This is where the tension begins. The public sees a smooth interface, a confident tone, and fast responses. But beneath that surface, the system is constantly trying to predict what the best answer might be, even when the data behind the prediction isn't strong. That gap, the difference between how the model works and how people think it works, is growing wider every month. And when gaps grow, consequences follow. The real challenge isn't that the technology is flawed. The real challenge is that people assume it isn't. They assume consistency where none exists. They assume certainty where none was promised. They assume accuracy because the tone sounds accurate. And once those assumptions take hold, the risk quietly shifts from the system itself to the people who rely on it without questioning it. Every major leap in technology brings enthusiasm. That's normal. But this moment is different because the adoption happened faster than the education. We moved from curiosity to dependence almost overnight. Something that started as a helpful tool is now shaping decisions in business, healthcare, communication, law, finance, and science. And because the adoption was so quick, the world didn't have time to build proper safety habits or deep familiarity. This rapid dependence can create hidden pressure points. People begin using the system for tasks it wasn't fully tested for. They push it into areas where even small errors can lead to serious consequences. And because the interface seems calm and confident, users assume the underlying logic must be equally steady. But the internal behavior of these models is still full of uncertainty. They shift, they adapt, they guess, and they fail quietly in ways that most people never see. What makes this moment even more complex is the speed of development. Every new version is dramatically more capable than the last. The upgrades are not slow, incremental improvements, they are major leaps. A model that was impressive in March can feel outdated by December. And while progress is exciting, it also means the systems are growing faster than society's ability to understand them. When technology outruns comprehension, imbalance forms. We're also watching an unusual phenomenon where large jumps in capability lead people to assume that the next leaps will be just as stable. But stability is not guaranteed. A system that performs well in one domain might behave unexpectedly in another. A model that excels under normal conditions might fail when pushed into unfamiliar territory. And because people rely so heavily on these models, even small cracks in reliability can create ripple effects across industries. All of this forms the backdrop for a conversation we need to have now, not later. When something becomes a central part of daily life, responsibility isn't optional. These tools are shaping economic forecasts, medical summaries, legal drafts, negotiations, code deployment, hiring decisions, and scientific exploration. And they are doing it whether people fully understand them or not. That's why awareness matters. The goal isn't fear. The goal is clarity. It's also important to address another factor that many people overlook: competition. The race to build better AI systems is intense. Companies feel pressure to release updates quickly, expand features rapidly, and push limits as far as they can. But speed can outpace caution. When rapid progress becomes the priority, long-term reliability can sometimes move to the background. And when the world depends on a fast-moving system more than the designers anticipated, the stakes increase dramatically. Expectations are another part of the puzzle. Public imagination treats these models as nearly flawless. People expect them to answer every question, solve every problem, and understand every intention. But unrealistic expectations always create disappointment. And disappointment in a system this widely adopted doesn't remain isolated. It spreads through businesses, governments, communities, and daily routines. So the question becomes, what happens when the world finally realizes that the technology isn't aligned with the image people have created in their minds? What happens when assumptions meet reality? Not because the system fails dramatically, but because people trusted it without recognizing its limits? That's the turning point the world is heading toward. And if we don't acknowledge that possibility early, we risk forgetting the most important principle of all. Powerful tools need careful guidance, realistic expectations, and clear understanding, not blind trust. The next section of this script will move deeper into what happens when rapid adoption meets uneven stability, and why the coming years may test the world's dependence on these systems in ways few people are preparing for. As adoption increases, something else begins to happen beneath the surface, something most people don't recognize until it's already influencing their decisions. The technology starts to feel familiar. It becomes part of daily routines. People stop treating it like a new tool and start treating it like an old habit. And when that shift occurs, they often forget that the system is still changing, still learning, still being updated, and still capable of unexpected behavior. A familiar tool that keeps evolving creates a false sense of stability. This becomes especially noticeable when the system gives an answer that sounds flawless. The phrasing is smooth, the logic feels convincing, the tone seems confident, but confidence in language doesn't always reflect confidence in reasoning. These models are built to generate the most likely response, not to challenge themselves or cross-check their own thinking. And when a system sounds persuasive, people rarely slow down to question whether the answer is actually correct. This is how dependence grows without anyone noticing. The tool becomes a shortcut. Then, the shortcut becomes the first step in the process. Eventually, it becomes the main step. That transition makes life easier until the moment a subtle error appears, and the user realizes they trusted the answer without understanding how it was created. Those quiet errors matter, because at scale, even small inaccuracies can influence thousands of decisions across industries. What complicates everything further is that people assume future improvements will remove these issues entirely. They expect each new version to be perfectly consistent, perfectly aligned, perfectly reliable. But improvement doesn't always remove unpredictability. Sometimes it shifts it into new forms. A model can become better at reasoning, while still struggling with rare edge cases. It can become better at writing while still misinterpreting tone. It can become better at analysis while still delivering confident mistakes in unfamiliar domains. Progress doesn't erase uncertainty, it simply moves it. As the systems become more advanced, the gap between what people imagine and what the models actually do becomes harder to see. The models feel more human-like, even though there is no human reasoning behind them. They feel more aware, even though they have no awareness. They feel more capable, even though their capabilities are still statistical, not experiential. And the more human they seem, the more people assume stability that does not yet exist. All of this leads toward a world where expectations rise faster than caution. And when expectations rise at that speed, a correction eventually follows. Not because the technology fails dramatically, but because the world assumed too much too soon. As more people rely on these systems, another shift begins that most don't see happening in real time. The technology starts influencing expectations about how quickly work should be done, how accurately information should be processed, and how smoothly ideas should be generated. Productivity standards begin to adjust around the assumption that these models are always available and always correct. That creates pressure, not just on individuals, but on entire industries that now shape their timelines around tools that still behave unpredictably under added strain. This pressure doesn't show up all at once. It grows slowly, in the background, as companies build plans, assuming the system will always perform at its current level. But these tools evolve constantly, and evolution doesn't guarantee uniform improvement. A version update might boost performance in one area while creating inconsistencies in another. New features might strengthen one type of reasoning while introducing instability in more complex tasks. The public rarely notices these shifts, but organizations built around the idea of flawless performance feel the impact when differences show up unexpectedly. There is also a growing challenge in the way people interpret answers from these systems. Because responses are delivered in a clear and confident tone, users assume the reasoning behind the text must be equally steady. But these models don't check their own assumptions or correct themselves unless guided. They don't pause to reflect or reconsider. They produce the most likely answer based on patterns, not the most carefully verified one. When people forget this, they treat the output as final instead of as a starting point. That mindset creates openings for mistakes that appear minor at first but expand when adopted at scale. At the same time, companies building AI tools feel immense pressure to maintain momentum. Every improvement raises expectations. Every new model raises the bar. Each step forward creates demand for another leap. When progress becomes measured by speed alone, important questions about consistency, reliability, and long-term behavior often get postponed. That doesn't mean the technology is unsafe. It means the pace of development sometimes outpaces the world's ability to adapt responsibly. And as these expectations continue to rise, something else becomes clear. The world is entering a stage where decisions, strategies, and predictions increasingly depend on systems that still have limits people rarely acknowledge. This doesn't mean the technology will fail dramatically. It simply means the margin for misunderstanding is getting smaller. And as reliance grows, that margin will matter more than ever. At this point, the world isn't facing a crisis, it's facing a decision. These systems can support extraordinary progress, but only if we approach them with clarity instead of blind confidence. The future will reward steady thinking, careful judgment, and patience. If we get that part right, the next era of AI will become far stronger than the one we're racing through now.